Okay, so for your test review, it's going to be on three equations, P equals mv, and with P equals mv, if I said initial momentum, then it's mass multiplied by the initial velocity. If I said final momentum, it's going to be m multiplied by the final velocity. Mass doesn't typically change. Impulse is this term, change in P is equal to F times T. That means force multiplied by time. And if I say change in momentum, then it means that I can do one of two things. I can take these two answers here and subtract them, so it would be P final minus P initial, or I can use this equation here, change in P, delta means change, by the way, you should know that, equals m, and then my change in velocity Vf minus Vi. I would do it this way, but this way is okay, and I'll do it this way on the practice problems. The last equation is combining these two together, and what I get is delta P, they both equal delta P, so what I get is F times T equals m Vf minus Vi. That will be the most difficult equation on the quiz. So for the first one here, these are just easy ones here. You got a 4 kilogram rock thrown at you with a velocity of 20 meters per second. What is the momentum? There are only two variables here, so you should be able to figure this out. I want you to list the mass, which is 4.0 kilograms, or you can mark it in the problem. This is mass. And then this right here is the velocity, so maybe I either write velocity down or I can label it as V, and that's 20 meters per second. And so I'm looking for P, so I need to have an equation that's got P, M, and V, and it's going to be this one right here, or actually this, it doesn't matter because there's only one velocity. So I multiply the two, so it would be 4 multiplied by 20, which gives me 80, and then the answer is kilogram meters per second. This question says if the rock were half the mass, well now they're saying that mass is 2, because it was 4, now it's 2. And we're to have the same momentum as the last problem, where the answer was 80. So now we know P is equal to 80. And they asked you, well, what would the velocity have to be? So they're looking for V. So all you're doing is taking P equals mv, and you're filling in the variables you have. 80 equals, and then we said 2 times V. I divide both sides by 2, and I'm going to get 40 for an answer, so 40 meters per second, which makes sense. It's got to go faster to have the same momentum. And again, I've gone over all these in class, so I'm going kind of quick here because you should have no problems. All right, this one here is an 8,000 kilogram. We'll make that a bus. Has an initial velocity of 30 meters per second. So label this m, label this initial velocity, and then it says the final velocity of the truck after it strikes this pole here is 2 meters per second in the same direction. So same direction means that that's also going to be a positive number. So I have final velocity, initial velocity, and mass. What is the initial momentum of the bus? P initial is equal to mv initial. So all I do is take 8,000 and multiply that by the initial velocity of 30 meters per second. And that gives me 240,000 kilogram meters per second. And notice I didn't put the units here. I don't expect ninth graders to do that, but the final answer must have a unit. And because this is kilograms and that's meters per second, they don't cancel out, so you just get kilogram dot meters per second. What is the final momentum of the bus? So P is equal to mv, and then that would be our final velocity. And I would substitute in here the 2 meters per second because that's my final velocity. I know this is kind of weird because the unit is separated, so apologize for that. So this ends up being 16,000 kilogram meters per second. It's less, and that makes sense with the story. If you hit a telephone pole, you slow down, you lose momentum. Solve for the change in momentum. Now this is what I said in the beginning here. You can use one of these two equations, either this one here or this one here. Now because we've done a lot of the work, I'm going to use this one and say, well, this is equal to change in P because we've already solved for these final and initial. But just be careful here. This is the final and this is the initial. So I subtract 16,000 minus 240,000. I know you're going to get a negative number, which is okay. So we get 224,000 kilogram meters per second, and that's got to be a negative number. All right, where did the missing momentum go? So if you've got a car or a truck or something that's traveling at some velocity and hits a resting object, that resting object is going to start moving. So the missing momentum went into the pole. and it's predictable as to what the velocity of the pole would be if it does move. Okay, this one's a little more complex here. You throw a dodgeball, or sorry, your teacher throws a dodgeball at your head with a velocity of 11 meters per second. It bounces off your melon, your head, with a velocity of 20 meters per second. So one of the two of these needs to be a negative number. The ball was going this way. Now the ball is traveling in the opposite direction after it hits the wall. So you need to figure out which one's going to be negative. I would make this one positive. So this is my initial velocity, and I'm going to write down plus 11 to make this a little bit easier. And then this over here is my final velocity. I'm going to write down negative 20. Now you could have done it the other way. It doesn't matter. This is the mass of the ball. So what's the initial momentum of the ball? Again, P is equal to mv. And this is also P equals mv because they won the final. For this one, it's going to be my initial velocity of plus 11 and then 0.5. So if I take 0.5 and I multiply that by positive 11, I'm going to get 5.5 positive. And I know it's positive. That's a good thing. Okay, then this over here is going to be the same mass. It doesn't change. A lot of kids are asking me, what mass do I put in this one here? It's the same mass. It's the same ball. And this is negative 20, and that's going to give us negative 10 kilogram meters per second. So now when they ask you what's the change or the impulse, well, impulse is one of two equations, or one of three actually. It's either this over here, which I don't have force and time, so it can't be that, or I can use either one of these two. This one would be preferable, but we've already done the work, so why not just use this one here and say P initial subtracted from P final. So for this one, be careful. This is the final. This is the initial. All right, so it's going to be P final minus P initial is equal to change in P. So if I put in my numbers here, it's negative 10 minus 11. Right? Sorry, not 11. Minus 5.5. 5.5 is a positive number, but I'm subtracting final minus initial. So it's final minus the initial, and that's going to give us negative 15.5 kilogram meters per second. If I did it the other way, if I used this equation over here, it would have been 0.5 multiplied by negative and then 20 minus 11. That would have still given us the same answer. Okay, what would happen to the force in your head if you were moving towards the ball? So imagine what's happening here. If this is the ball moving towards your head and you're moving in the same direction, all right, if I look at this equation, mvf minus vi equals f times t, and I think about the variables that will change, well, mass never changes. My final velocity would change. I would be pushing on this a little bit harder because my head is moving in the same direction. So the force would go up, which would cause the ball to have a different final velocity, and it would be a higher number. And also it would change the time of impact. You know from the activity we did, if the force goes up, then it means that the time of impact is less. These two things have an inverse relationship. It means that they have an opposite relationship. Solve for the time of impact. Solve for the time of impact between your head. Solve for the force. My mistake. If the time of the impact between your head and the ball is 0.1 seconds. So more than likely, if I'm asking a question like this, you know it's going to be a longer equation. So we've already figured this out here. We already know that delta P is equal to F times T. Because I had the word force and I had the word time in here, right, or I had a time, you should know that when you look at your list of equations, there's only one that has force. It's this one right here. This one. So if I hadn't solved for this, then I would probably go to this one here. But I've already solved for delta P. We already said it's negative 15.5. So I'm going to substitute those values in there. I'm going to say, well, delta P is this, right? So just fill in the variables. 0.1 seconds. Well, 0.1 seconds is the time, and F we don't have, so it would be 0.1 F. We just divide both sides by 0.1, and that's going to shift the decimal over and give us 155 newtons. Make sure you got a force there, a unit for force. Okay. Imagine the same situation above. This time your teacher throws the same wrench, same mass, but it's a wrench, and a wrench is less. It's not flexible at all, actually. So which variables would be different? So again, we go back to this equation here and say, well, it's just like the last explanation. The force is going to go up because the time drops. The wrench doesn't flex when it hits your head. When a ball hits something, the ball actually flexes, like it turns like, you know, it crushes in on itself, and then it springs back and then pushes off. A wrench won't do that. So a wrench has a really small time, which means that the force goes up. So F goes up, T goes down, and your final velocity will more than likely go up. And again, we don't have to do this here. We did that in class. This one here is you got 160 grams. Be careful with this. It's 0.16 kilogram ball, baseball thrown at 26 meters per second. You hit it back in the other direction, and it leaves with a final velocity of 34. So I've got two velocities, and I've got a mass. All right. The bat is in contact with the ball for 0.0006 seconds, so that's t. And people are struggling with identifying variables. Use the context clues: seconds, kilograms, meters per second, meters per second. Those things mean something. What's the ball's initial momentum? This again, P equals mv, because they're only asking you for momentum, not change, not force, and not time. So I just substitute my values in here: 0.16 multiplied by, and then 26 meters per second. So 4.16. And again, I'm going to go kind of quick here because I'm running out of time in this video. This one here, final momentum of the ball. Again, the mass of the ball doesn't change, so it's going to be 0.160 multiplied by 34. Now it's got a different velocity. It's got a higher velocity because you hit it with a big force, but also it's a negative number because you're hitting that ball in the opposite direction. So if I multiply these two here, 0.16 multiplied by 34, that gives me 5.44, but I know that's a negative number. All right. What's the change in the ball's momentum? Again, we've already figured out the momentum change, the momenta, so we're going to subtract the two, negative 5.44, which is the final, minus the initial, which is 4.16. And that's going to give us negative 9.6 kilogram meters per second. So again, what does this mean? Well, this means that the ball has a pretty big momentum because it's actually been hit really hard, and it's going fast, and it's also going in the opposite direction. For this one here, what's the average force? Well, again, you go back to the top here and you find your equation, and there's only one equation that has F in it, right? This one is really just these two combined, but this is the equation you're going to use. So F equals F times T equals delta P. So I go up to the top here, so I go down to the bottom here, and I add in my equation. F times T is delta P. We already said what delta P is, so it's negative 9.6 equals F we don't know, but we know T is 0.0006 F. And so we take both sides and divide by the time. That cancels out, and we end up with 9.6 divided by 0.0006 is 16,000 newtons, and because this is negative and we're dividing by a positive, that's a negative number. Now why is it negative? Because the ball is going this way, it's pushed with a force to the left, and we know left is a negative force.